In this video, we're going to talk about what is inertia, how is inertia related to mass. In the absence of unbalanced forces, what can be said about an object's motion? The groundwork for Newton's first law of motion was laid by Galileo. In his experimental investigations, Galileo dropped objects to observe motion under the influence of gravity. Galileo Galilei did his famous experiment by dropping different size of balls from Leaning Tower of Pisa. We know that from free fall. However, the relativity large acceleration due to the gravity causes dropped objects to move quite fast and quite far in a short time. Though the experimental measurements for free fall, distance versus time, were particularly difficult to make with the instrumentation available in Galileo's time. To slow things down so he could study motion, Galileo used balls rolling on an inclined planes. He allowed a ball to roll down on an inclined plane and then up another with a different degree of incline. Like suppose here's the inclined plane and here's another incline. So this Galileo noticed when the ball was rolled, it would just go up on the other incline to the same height. Then he changed the incline on the right side a little bit in a different degree. One thing that he noticed that as he changed the degree of the incline, the balls reached the same height in every incline, like here and here. So the height was the same for all of them. So Galileo noted that even though the balls rolled to approximately the same height in each case, but it rolled further in the horizontal direction when the angle of incline was smaller. So when he allowed to roll onto a horizontal surface, the ball actually traveled considerable distance and went even further when the surface was made smoother. Galileo wondered how far the ball would travel if the horizontal surface could be made perfectly smooth, frictionless. Well, this situation is impossible to attain experimentally. Galileo reasoned that in this ideal case, with an infinitely long surface, the ball would continue to travel indefinitely with a straight line, uniform motion, with no acceleration, since there would be nothing or no net force to cause its motion to change. The ball would actually slide, not roll. Let's note that in this ideal case of the absence of friction. According to Aristotle's theory of motion, which had been accepted for about 1900 years prior to Galileo's time, the normal state of a body was to be at rest, with the exception of the celestial bodies, like the bodies in the sky, which were thought to be naturally in motion. So Aristotle, no doubt, observed that objects moving on a surface tend to slow down and come to rest. So this conclusion would have seemed logical to him. However, from his experiments, Galileo concluded that bodies in motion exhibit the behavior of maintaining that motion. And if an object were initially at rest, it will remain so unless something caused it to move. Galileo called this tendency of an object to maintain its inertial state of motion inertia. That is, inertia is the natural tendency of an object to maintain a state of rest or to remain in uniform motion in a straight line. For example, if you ever tried to stop a slowly rolling object by pushing on it, you felt its resistance to change in motion. Physicists describe the property of inertia in terms of observed behavior. Newton related this concept of inertia to mass. Originally, he called mass a quantity of matter, but later redefined it as mass is a quantitative measure of inertia. That is, a massive object has more inertia or more resistance to change in motion that does a less massive object have. For example, a car has more inertia than a bicycle. Now, Newton's first law of motion sometimes is called law of inertia, summarizes these observations. In the absence of unbalanced force, where the F net is 0, all the forces add up together to 0, a body at rest remains at rest, and a body in motion remains in motion with a constant velocity. This is if the net force acting on an object is 0, then its acceleration is 0. If F net equals 0, then acceleration is also 0. It may be moving with a constant velocity or be at rest. So this could mean that velocity is constant or velocity equals 0. All we require is that delta V, the change in velocity, is 0. Thanks for watching. Stay tuned for more.